Hey guys, day one and I worked on 5 problems. So the first one was jewels and stones. So let's start, since it's day one, we are going to start from an easy level question. And so jewels and stones, I'm quickly gonna go over this 5 questions and the solution to these problems. Alright, let's go to the first one. And the first one is saying that you have jewel, a J that is a string, and it represents different stones that you have, and these stones are jewels. And this S is different types of stone that you have. That's your own stones, but this one is just a representation of what stones are jewels. So, and then they're asking you to check if your stones are jewels. So how do you do that? In order to do that, the simple brute force solution is to first go through each of your stones and check if your stone is present in J. If it's present, that means your stone is jewel. So this is a brute force solution, but a better solution. So if you use brute force solution, you have to go through each element and then check. So that's a nested for loop, and that would give you order of length of S and length times length of J. So the better solution would be to use a hash map and store different types of jewels, and you do one pass through S and check if it's in the hash map. If it is, then that means it's a jewel. So you increment it. I'll just show you the code very quickly. So here, like you have a hash map, and you go through each letter in jewel, and then you put it in the hash. Or you could put it in a set, because set doesn't take duplicates, and the check is also order of 1 from the set. The stone, and you increment the counter, and you just return the counter. So that's pretty much for the first problem, and we go to the next problem. So the next problem says that you have email, and this is a domain part of the email, and this is this is a local name, and this is a domain name actually. So, and they're saying that the local part of the email could contain dot and plus. Even though it could contain dot and plus, if it, for example, contains dot, when you send the email to alice.leetcode.com, it would go to alice@leetcode.com. So it just ignores dot part. However, if you have plus in it, it just ignores everything after the plus, but it doesn't ignore the domain part. It just ignores up to @ symbol. So how do we solve this problem? And then they're asking you, and say given a list of, you have a list of emails, and you have to figure out how many actual emails how many actual addresses receive the mails. So for example, let's say alice.k@gmail.com. when you send the mail to this person, it actually sends a mail to alice.k@gmail.com, because it just ignores dot. So if you send mail to alice plus k@gmail.com, actually sends a mail to alice@gmail.com. So that's because it ignores everything after plus. This rule only applies in the local name of the email address. So how do we do that? The very simple solution is basically you first have to split the local name. So if we have alice dot plus s@gmail.com. So the first thing we do, we have to split it by @ symbol, and we split the local part from the domain. So this is a first, so we split it by And then once we have a local, we can actually split this by, if there's a plus sign, you could actually split it by plus sign, or so if I split this by a plus sign, this would have Alice plus S, right? So I'm just going to ignore everything of the plus, and I'll make a new domain name, Alice dot, and I will also check if Alice has a dot, so I can also replace. I could just remove dot from here and turn it into Alice, and at the end I'll just return Alice gmail.com, and I'll just add them all together and return it. So basically, it's a couple steps, just easy problem. And here's and then you go through each email, and then you call this receive mail function, and you add that to email set, and it should be easy. Submissions they have, solutions they have offered, it's very similar. So, and the time complexity order of the email in the in the email list, because you have to go through each emails. So that's pretty much for the unique email address. So let's go ahead. The third question is find anagram mapping. So first of all, what is anagram? Anagram is it's basically a word that, for example, let's say by rearranging the letters in the word, you can make up another word. You can create another word. Let's say cinema could be transformed into ice cream, actually. So as a result, they are giving you two lists, A equals to B, and here you have 12, and A is anagram of B, and they are anagrams of each other. So that means they have the same letters, but they're in order differently, so they're not on the same position. Like cinema, C is at the beginning, while in ice cream, C is in the second position. So that's why you have numbers 12, 28, 13, for example, and B is just the same elements, but and they are ordered differently. So they just want to tell, and they just want you to return a list that that contains the index elements of where the elements in array A are at in array B. So for example, 12 is at index position 1, 28 in index position 3, 2, and then 13 is index position 0. So how do we do that? The brute force solution is to go through each element in A and then check if it's here. The better solution would be to store everything from B in the hash, and only pass through A once and check if it's in hash. If it is, then in the response array, store the index of that. So how did I solve this problem? I'm gonna go to submissions and show you the details. Alright, so here, as I said, if anagram word or letter formed by rearranging letters of another word. So I used the list comprehension with dictionary. So what did I do? So first I create a response array, and I initialize this values to none. So my dictionary has elements, and it's the key is the element, the current element, and the index of that element. So what I did was it's a list comprehension using a dictionary value, so and key. So the key is actually the current element, and the value is a current index. So enumerate gives us these two options. So if you're looping through array, it's going to give you the current element and the current index. So that helps us to create a mapper dictionary hash map. So and then after that I loop through each element in the array, A, and then I checked. I basically then response I was the mapper. Since I'm sure that AJ, the elements in A exist and B, I just access that in the mapper, and now the value of that key would be equal to the will be the current position, the position of the B element, the position of the element in A in B. So since mapper contains the mapping between the elements in B and their index, their position. And then finally I return the response. So two new things I learned here, just list comprehensions, dictionary, and anagrams. That's pretty much for the third problem. Let's go to the next one. The next one is called Big Countries. This is a sequel, and you have a sequel. You have a world table, and they want you to return countries where the population is more than 25 million, and then the area is bigger than 3 million square. So the very easy way to solve this problem would be where. So you just say select name. So they want you to select name population array. So select name population array from world where world dot population is greater than 25 million, and world dot or. So they said or, right? So or world dot area greater than 3 million, which is in numbers, and this would return you all the. But the another way to solve this problem would be unions, using a union. You know that union returns elements that are either present in A or in B, or if they are present in both. So that means that since here they are asking you to return, it's either 25 million, greater than 25 million, or it's greater than 3 million. So what if we just do one query for select name of the country from world where world dot population greater than 3 million. Instead of saying or, we could actually do a union, which should be a union. Select name from world where world dot area greater than 25 million. So this is a different way of solving it. Just if you learn about sets, the sets have this union operation where so if you have like 1, 2, 3, and you have another one called 1, 2, 3, 4. As I said, if you take the union between them, so if it's A, B, A union B, that would give you, as I said, the elements should be present either in A or B. So currently 1 is present in both. So that means in set, as I said, two rules. A, element should be present in both, or element should be present in A or B. So over here 1 is present in both, so that's true. We're going to add 1 here, and 2 is present in both, and 3 is present in both, and then finally the 4 is present in B, but it still would be included in the set because it's a union rule. So that's why union also works. The straightforward solution was used this one where, but this is an easy problem, so it doesn't take too much time to solve it. Alright, so after this I worked on flipping an image. So you're given a binary matrix, and what you want to do is flip it horizontally. So binary matrix, just remember, it's a 2D array that has 1, 0s, and 1s in it. So, and then let me create 1, 2, 2, 0, 0. So basically they want you to flip it flip it horizontally. By flipping horizontally, they mean just reverse the entire array, the entire row. So you first have to reverse it, and the second thing is invert it. Inverting means if it's 1, it turns into 0. If it's 0, it turns into 1. So what I did was my solution to do that. So what I did, okay, let me give you this one. So what I did is that I went through each element, each row in the array, and I flipped it, and I reversed it. So by having I and j, and while j is greater than I, then we are flipping left and right. And after I flip it, then I'm changing the value, the current value, to 1 if the flipped value is 0. If it's not, if it's not 0, then it would be 1. If it's if it's 1, it would be 0. Same here. So there's one part I was kind of stuck at, and that's because I only reversed while j was greater than I. If while j is greater than I, it only reverses the even sides. It doesn't reverse the middle. So, and then my algorithm did not actually invert the middle. So the solution to this was actually also go to the middle if it's odd, and flip it with itself. And then once you flip it, then you also you should invert it afterwards, so that it gets inverted too. So yeah, that's pretty much. And I was kind of stuck at it, but I was able to figure it out by just printing the array after assignment, after flipping and all that, and I was able to figure it out. So, and also if you notice here, I'm using if. So since if it's 0, if it's 1, then it should be 0, and I'm assigning 0. If it's 0, then I'm assigning 1. But the better way to do this would be use bit manipulation. You have something called XOR. So what XOR is that, so it's a digital logic gate that gives a true output when the number of true inputs is odd. So if it's opposite to each other, if 0 and 1, that would give you true, which is 1. If it's 0 and 0, that would give you 1. So if it's 1 and 1, it would give you 0. So in our case, what we could do is that we could say input XOR to 1. So imagine if our input was 0, since they are opposite, that would give us 1. So your input is 0, so that means they want you to invert it to 1. But so if you XOR it with 1, that would give us 1. That's what we want. But what if the input was 1? We want it to be, in order to invert it, we have to turn it into 0, right? But if you XOR it with 1 again, that would, if there are, and this wouldn't give us high, the 1 anymore, it would give us 0. So because they're not opposite of each other. So that's why the better way of doing it is basically XOR the current value was 1, so it would just give you the opposite. So if you have 1 here, that if XOR was 1, it would give you 0. If you XOR was 0, it would give you 1. So that's a cleaner way of doing it instead of writing if-else statement. Yeah, that's pretty much was the last problem. So today I solved 5 problems, and tomorrow we hopefully going to solve around 5 more problems. So yeah, I guess see you guys later. Happy coding.